Let's go ahead and talk about using the remainder and factor theorems. We're going to be working with the function f of x equals x cubed plus 3x squared plus 2x minus 1. And we want to know what the remainder is when we divide that by x plus 2. So we've already taken a look at synthetic division and long division. So let's talk about finding the remainder using the remainder theorem. Our first step here is that we need to go ahead and find the 0. So we're working with the factor of x plus 2, and we can go ahead and set that equal to 0 so that we can solve for our x value. And in this case, our 0 is going to have an x value of -2. And what we want to do is we want to come up to our function and we want to plug in that -2 so that we can calculate f of -2. The answer that we get is going to be the same thing as if we had done synthetic division and found the remainder that way. So let's go ahead and plug in the -2 into our function. We're going to get -2, the whole thing cubed, plus 3 times -2 squared, plus 2 times -2 minus 1. And let's go ahead and simplify what we've got. -2, the whole thing cubed, is going to give us -8. This next part is going to give us 3 times a positive 4. And we're going to get -4 minus 1. So let's go ahead and simplify this. We've got -8 plus 12 minus 4 minus 1. So once we add those numbers together, this is going to give us a value of -1. Right, so our remainder after we do this division is going to come out to be a -1. And let's go ahead and verify this. Let's try it with synthetic division, just so you can see that it actually works, and it gives us a chance to review synthetic division. Keep in mind, when you're working with synthetic division, you're going to need each of your coefficients from your terms of your function. We don't have any terms that are missing, so we don't have to replace anything with a 0. And the thing that we're going to be dividing by in this case is the -2, since that was the 0 we were working with. Alright, so let's go ahead and start our synthetic division. We'll drop down the 1. And -2 times 1 is going to give us -2. Remember, at this stage we are adding up and down. That'll give us a positive 1. -2 times 1 will give us a -2. When we add up and down here, we're going to get 0. And -2 times 0 is going to give us 0, so that when we add up and down, we'll get -1. And this last piece was our remainder with synthetic division, so it worked out. In this example, we're going to be taking a look at the factor theorem. And the factor theorem says that if we can divide this out evenly, right, we get a remainder of 0, then the x minus c part is going to be a factor of our polynomial. So the function that we're going to be working with is f of x equals -2x cubed minus x squared plus 4x plus 3. And we want to know if x plus 1 is a factor. So we're going to go ahead and find our 0 from the factor. We'll take the x plus 1, set it equal to 0 to solve it for x. And so we're going to be working with a 0 of -1. And we want to go ahead and plug that into our function. So we're going to calculate f of -1. So we've got -2 times -1 cubed minus a -1 squared plus 4 times -1 plus 3. And you want to be careful with your negative signs here. Alright, let's go ahead and do this in stages. We've got -2. The -1, all of that cubed, is going to give us a -1. This minus sign is that one, right? We've got -1, the whole thing squared, That's going to give us a positive 1. 4 times negative 1 would be a negative 4. And then we have the plus 3 at the end. So this will give us positive 2 minus 1 minus 4 plus 3. And if we add these together, we're going to end up with 0. So the 0 was our remainder, and because we got 0 in this case, the answer to our question is yes, x plus 1 is a factor, because it divides out evenly. Anytime you get a remainder of 0, then you can say yes, what you were working with, that factor, is a factor of the polynomial.